Assalamu alaikum. I am Mohammad Jahangir Alam, lecturer in physics. I welcome you all in my online class. First of all, thanks to Almighty that He has given me the ability to take this class. Dear students, I also hope all of you are well with your families, staying at home and carrying on your regular studies. Dear student, in our previous class, we have learned about the multiplication of vector. That is, there are two types of multiplication of vector. One is vector multiplication and another is scalar multiplication. If the product of two vector is a vector quantity, then this type of multiplication is called vector product or vector multiplication. Again, if the product of two vector quantity is a scalar quantity, then this type of multiplication is called scalar multiplication, right? In our today's class, we will discuss about the vector multiplication and scalar multiplication of rectangular unit vector. Dear student, first we will see the scalar product of rectangular unit vector, and you know what the unit vectors are. I, j, k, these are known as rectangular unit vector. In three-dimensional coordinate system, the three unit vectors represents the direction of three positive direction of x-axis, y-axis and z-axis. These unit vector I, j and k are known as rectangular unit vector. You know, in your previous lecture you have already learned that the dot product of two vector. If two vector are denoted by a and b, you know a and b are two vector. If we would like to get the dot product of two vector, then the result will be a scalar quantity, and the value of the scalar quantity which depends on the magnitude of the two vector. That is, if the magnitude of a is denoted by simple a and magnitude of vector b is simple b, and angle between a and b is theta, then the value of this expression or value of the dot product of a and b will be a b cos theta. This is a magnitude only. Dear student, here I, j and k are also a vector, though their magnitude is 1, but they are vector here. So we can get the dot product of a, I, j and k. Here, if we would like to multiply I dot I, so what will be the result? According to the expression, the magnitude of a dot product will be depends on the magnitude of the vector and the cos theta, that is angle of cos of angle between the two vector. Dear student, here the magnitude of two vector I and I are 1, both are unit vectors. So magnitude of I and I and both are I, so magnitude of these two vector is 1. So we can write that I dot I is equal to 1 multiplied by 1 multiplied by cos. Here the angle between I and I, from this figure you can see that I indicates the positive x direction. So the direction between I and I, both vector are in the same direction, that is they indicates the positive x axis. So the angle between I and I will be 0. So cos 0 degree, and you know cos 0 degree gives the value as 1. So 1 multiplied by 1 multiplied by 1. So ultimate result will be 1. Similarly, j dot j is equal to 1, k dot k is equal to 1. That is, the dot product of two similar vector I dot I is equal to j dot j is equal to k dot k is equal to 1, right? Dear student, the dot product of two similar unit vector is 1. Two similar unit vector is 1. Now we can see I dot j, I dot j. Now we are going to the dot product of two unit vector or two different unit vector, here I and j. So according to this expression, the value of the expression will be 1 multiplied by 1 multiplied by cos. Here the value of I is 1 and value of j is also 1, but the angle between I and j, from the figure you can see that the angle between I and j, that is the angle between x axis and y axis, is 90 degree. You know these three axes are mutually perpendicular to each other, so angle between x axis and y axis will be 90 degrees. So here value of theta will be 90 degree. You know the value of cos 90 degree is 0. Value of cos 90 degree is 0. So ultimate result of the expression will be 0. Similarly, we can write that j dot k is equal to 0 and k dot I is equal to 0. So we can write that I dot j is equal to j dot k is equal to k dot I is equal to 0, right? So dear student, we can say that the dot product of two different rectangular unit vector, dot product of two different rectangular unit vector will be 0 always. The commutative law, that is I dot j and j dot I are the same thing. Okay, right. Dear student, now we are going to see the scalar product of two vector result in three-dimensional coordinate system, right? Suppose let A is a vector, A is resolved in three-dimensional coordinate system, that is ax I plus ay j plus az k. Similarly, vector B, it's another vector, B is equal to bx I plus by j plus bz k. Vector A is resolved in three-dimensional coordinate system, that is A has three component. This component along x axis, this is along y axis, and this component is along z axis. Similarly, B has three component, bxi, byj and bzk. Now we are going to get the result of the dot product of these two vector, right? Now A dot B, right? So the value of A is axi plus ayj plus azk dot bxi plus byj plus bzk. Dear student, this part contains three term and this part contains three terms. So according to the basic concept, the product of these two expression will be, first we will multiply this component with this component, that is ax bx into I dot I, right? These are not the vector part, these are the scalar quantity, but we have to multiply I with I because these are vector. So product of these two part should be calculated carefully, and we will multiply ax with byj. So ax by into I dot j, right? Similarly ax with bzk, so ax into bz into I dot k, right? Similarly, now we are going to get the product of ay with these three terms. So ay bx, that is j dot I plus ay by j dot j plus ay bz j dot k. Similarly, we will multiply az with these three terms. So az bx, so k dot I plus az by, so k dot j plus az bz here k dot k. Dear student, from our previous calculation we have already learned that if we get or if we multiply two similar rectangular unit vector, that is I with I, j with j and k with k, then we will get 1. But if we multiply two different rectangular unit vector, that is I with j or I with k, then we will get 0. Here I dot I, here I dot I, so this part will give 1, I dot j, this part will give 0, I dot k, this part will give 0, j dot I, this will also give 0, j dot j, this will give 1, j dot k, this will give 0, k dot I, this will give 0, k dot j, this will give 0 and k dot k, this will get 1, because here I dot I, there are two similar rectangular unit vector. So I dot I, j dot j and k dot k, these three part will give 1 and remaining 6 part will give 0. So here we will get, so ax bx into 1, that is ax bx, and plus this will become 0, this will become 0, plus this term will become 0, plus this term will become 1 with ay by. So ay by plus this term will give 0, and lastly az bx will be 0, k into j will become 0 and k dot k will give 1. As a result we will get az bz, right. So finally we can write that a dot b is equal to ax bx plus ay by plus az bz, right. This is the final expression for the dot product of two vector resolved in three-dimensional coordinate system. Here you have to mind that only the corresponding component ax bx, that is these two components related to x axis, these two components related to y axis, this component related to z axis, only the corresponding component will remain and other component will become 0, right. Okay, my dear students, now we are going to find dot product or scalar product of a and b. Here a and b both are two vector resolved in three-dimensional coordinate system. That is, a has three component, one part is along x axis, along y axis, along z axis. Similarly b has three components, so we have to find the dot product of the two vector. So in our earlier discussion we have learned that the dot product of two vector which are resolved in three-dimensional coordinate system can be expressed as a dot b is equal to ax bx plus ay by plus az bz, right. Here the components of a has three components, 2, 3 and 5. So ax is equal to 3, ay is equal to 3, sorry, ax is equal to 2, ay is equal to 3 and az is equal to 5. Similarly, three components of b here, so component of b vector along x axis bx is equal to 1. Here the coefficient of I is 1. So by is equal to minus 2 and bz is equal to 3. So these are three components for a and these are for b. Now we are going to use the value of ax bx ay by az bz. So ax is equal to 2 multiplied by bx is equal to 1 plus ay is equal to 3 multiplied by by is equal to minus 2, az is equal to 5, bz is equal to 3. So here 2 minus 6 plus 15. So after the calculation you will get 15 plus 2 17 minus 6 11. So dot product of a and b is equal to 11, right. That's right. Now we are going to see the vector product. Here we are going to see the vector product of rectangular unit vector I, j, k Okay, so you know the vector product of two vector is a vector quantity. If two vector A and B are two vector, if we would like to get the vector product of A and B, then we have to use a cross sign between them. That's why vector product is also known as cross product. So it will gives a vector quantity. The magnitude of this vector, that is the magnitude of A cross B, will be A B sin theta, and direction of A cross B will be perpendicular to both A and B, right? Here eta is a unit vector whose direction is perpendicular to both A and B, which will be determined using the right-handed screw rule. Okay, so it has two parts, one is magnitude and second one is direction. Now here I, j, k, these are also vector, so vector product is also applicable for this rectangular unit vector I, j and k. Dear student, if we multiply like I cross I, that is cross product of I and I. So according to this law, the cross product of two vector will gives two part, that is first part indicates the magnitude and second part indicates the direction of the vector. So here the magnitude of I cross I, here the magnitude of A cross B is equal to AB sin theta. So here I cross I gives 1 multiplied by 1, because the magnitude of I is 1 into sin. So what will be the theta in case of I cross I? You know, I indicates the direction of positive x-axis. So if we get I cross I, then the angle between I and I will be 0 degree, right? And direction eta, you know, sin 0 degree is equal to 0. So magnitude will be 0. Since the magnitude will be 0, so it will be a null vector, that is we will get I cross I is 0. Similarly, j cross j is equal to 0, k cross k is equal to 0. So we can write that I cross I is equal to j cross j is equal to k cross k is equal to 0. That is cross product of two similar vector. Cross product of two similar rectangular unit vector will be 0, right? Now we are going to get the cross product of I cross j. Here I and j are two different rectangular unit vector. So what will be in this case? Dear student, according to this expression, first we will get the magnitude of I cross j. Here magnitude of I and j will be 1 into 1, then into sin. So what will be the angle between I and j? From the figure we can say that angle between I and j is 90 degree, right? And eta is the unit vector. You know, sin 90 degree is 1, so 1 multiplied by 1 multiplied by 1. So we can write that here 1 into eta, that is eta. So first you have to understand eta is a unit vector, its value is 1 and it has a direction. So in our previous lecture you have already observed that the direction of eta indicates the direction of the product of A cross B, and which is perpendicular to both A and B. Here direction of eta is perpendicular to both I and j, right? Direction of eta will be perpendicular to both I and j. So from the figure you can realize that the perpendicular direction both I and j is z axis. Okay, so it is a unit vector whose magnitude is 1 and its direction is both perpendicular I and j. So from the figure you can realize that k is a unit vector whose magnitude is 1 and whose direction is both perpendicular to I and j. So we can say that eta is nothing but k. So from this expression we can write that eta is k. So I cross j is equal to k. Similarly, we can write that j cross k is equal to I and k cross I. K cross I is equal to j. Dear student, you know cross product obeys commutative law. So in that case, you can write that if I cross j is equal to k, then j cross I is equal to minus k, right? When you will multiply it j cross I, then you will get k but in opposite direction. Okay, so k cross j, here j cross k is equal to I, so k cross j will be minus I and I cross k will be minus j. So I think you got it. Now we can see a technique to mind this, keep it mind, how can we recall this expression. So when I cross j is equal to k বা j cross or j cross k is equal to I, there is one, the technique is, if we show the clockwise direction, suppose here is I, j and k. In the expression you already observed that when you multiply I cross j, then you will get k. When you multiply j with k, then you will get I. When you multiply k with j, then you will get j. So if the rotation or order follows the clockwise direction, then the result will be positive, that is I to j in this direction, clockwise direction. So I cross j will be positive k, right? But when it in the opposite direction, here is I, here is j and here is k, right? When in the opposite order or reverse order, then you will get negative direction. So I cross j is equal to k, but when the rotation take place in the anti-clockwise direction, that is when you will get j cross I, that is j to I, anti-clockwise rotation, then you will get minus k, right? So similarly you can get the other expression. Okay, dear student, now we are going to observe the vector product of two vectors resolved in three-dimensional coordinate system. Like suppose A is a vector, it has three components, axi, ayj plus azk. Similarly, B is also a vector, it has also three components, bxi plus byj plus bzk, right? Now we are going to get the vector product or cross product of A cross B. Here A cross B is equal to axi plus ayj plus azk. Okay, we will use a cross sign here. So bxi plus byj plus bzk, right? Here ax, ay, az, bx, by, bz are the magnitude or value only, but you have to be careful about I, j, k. Okay, so when we multiply axi with bxi, so ax, bx, these are two magnitude only, there is no problem, but you have to be careful about I cross I, right? Similarly ax, by, so I cross j, and ax, bz, so I cross k, right? Now ay will be multiplied with these three components, so ay bx, so j cross I plus ay by j cross j plus ay bz, so j cross k, right? And lastly we will multiply azk with these three components, so az bx, so k cross I plus az by k cross j plus az bz k cross k, right? So in your previous calculation we have already learned that when we multiply or when we get to the cross product of two similar rectangular unit vector, that is I cross I, j cross j, k cross k, this will give 0. So I cross I, j cross j and k cross k, this will give 0. Here I cross j, here I cross j, here the order in clockwise direction, so it will give positive k. K I cross k, this give the reverse direction or anti-clockwise direction, so it will give minus j. Here I cross j, it will give minus k, j cross j, it will be 0, j cross k, it will give I, k cross I, it will give j, k cross j, it will give minus I, right? Dear student, from the expression now we can write here I cross I is 0, so this term will be 0, 0 plus I cross j. So in your previous calculation you have already learned that I cross j will give k, so a x by into k. Similarly I cross k, it will give minus j, so we will get minus ax bz into j. Okay, dear student, you know j cross I, it will give minus k, so minus ay bx k, and j cross j will be 0, so this total term will be 0. Here j cross k, it will give I, so ay bz into I. Here k cross I, it will give j, so plus az bx into j. K cross j, it will give minus I, so minus az by into I, and finally it will be 0. So our expression become ax by dear student, among the remaining 6 term 2 is associated with k, that is ax by into k and ay bz into k. Similarly 2 terms will associated with j, that is ax bz j and ax b az bx into j, and 2 terms will remain associated with I, ay bz I and az by into j. So we can write, if we take the term associated with I, this term is associated with I, so we can write ay bz minus this also associated with I, so az by into I plus this term and this term is associated with j, so we can write az bx minus ax bz into j plus this term and this term is associated with k, so we can write, so ax by minus ay bx into k, right? So we can write a cross b is equal to this one, but I think this expression is very difficult to keep in mind, so we can apply a technique to keep it in mind and we can recall it easily. Dear student, you can rearrange this expression. You can rearrange this expression like indeterminate form. That is, a cross b is equal to, you can write indeterminate form I j k ax bx ax ay az bx by bz. So after the calculation, this determinant, it will give the same expression. So I think this expression is much more easier than this expression, right? So in case of cross product of two vector resolved in three component, we will use this expression. Now we will see a mathematical problem related to cross product and dot product. They said that whether A, B and C are coplanar or not. You know what is coplanar? If two or three vectors lie on the same plane, then they are said to be coplanar. So here we have to verify whether A, B and C are coplanar or not. To verify this three vector, dear student, if we prove that A cross B dot C is equal to 0, you can also get the dot product of A with the cross product of B and C, like A dot B cross C. Okay, that is the dot product of any vector with the cross product of other two vector will become 0. Then these three vector will become coplanar. So now we have to find the value of this expression. If the value of this expression becomes 0, then we can say that these three vector are coplanar. Or if the result of this expression not 0, then they are not coplanar, right? Actually, this expression give the volume considering three sides of a parallelepiped indicated by A, B and C. So if the volume is 0, then these three vectors are lie on the same plane. So we have to determine first A cross B, then we will get the dot product with the product of A cross B with C. That's when you know the A cross B in the determinant form I J K, right? So AX AY AZ BX BY BZ, right? Here I J K. Here AX means 2, so 2, AY means 3 and AZ means 5. Similarly BX means 1, BY means minus 2 and BZ means 3. Here student, so here you know how can we calculate the determinant. So if we get I, then we have to omit the column and row associated with I. So here the product of this component and this component. So first we multiply 3 with 3, that is 9. Then you have to use a minus sign. Then you will multiply this component with this component, right? So here 9 minus 10. So it will give 10. Then you will get minus j into, then you have to omit the column and row associated with j. So this row and this column. And here you have to multiply 2 with 3, this component with this component. So it will give 6 minus 5 plus k. Here we have to omit this row and this column. So first you have to multiply 2 with minus 2, so it will give minus 4, then it will get, you will give the product of 1 with 3. So here we can get 19i minus j and minus 7k. So this is the cross product of A cross B, right? We are going to get A cross B into C. So the A cross B gives 19i minus j minus 7k. This gives A cross B dot C. So C gives 3i plus 2j minus k. So after the dot product you will get AX BX, right? Here 19 into 3, 19 into 3 plus the coefficient of j is minus 1. So minus 1 into 2 plus coefficient of a 7 into minus 1, right? So here 57 minus 2 plus 7. So it will give 64 minus 2, that is 62. So dear student, A cross B, here A cross B dot C is equal to 62. So we can say that A, B and C are not lying on the same plane, that is they are not coplanar. Okay, dear student, I think you have got it. So no more today. This is about the dot product of rectangular unit vector and cross product of rectangular unit vector. Got it? Okay. But if you have any confusion, you can call us or you can contact your subject teacher. So thank you very much being with me in my class. May Allah bless all of you. Assalamu alaikum.